presentation on Ebean ORM's persistence context. So what we're going to look at is the job of the persistence context, which is to ensure unique instances, and the fact that it's not involved in persisting. So this is effectively a comparison to JPA's persistence context. We'll look at some scopes, transaction scope, query scope, and the object graph scope that's used in find each. And at the end we'll look at the concept of what the object graph that's being returned by an ORM query is. Essentially it's a snapshot of part of the database. We'll talk about isolation levels and about the database doing the heavy lifting to support high concurrent workloads. But firstly, the JPA has a persistence context definition which has got two parts to it. The first part is a persistence context is a set of entity instances in which for any persistent entity identity there is a unique entity instance. So when we say persistent entity identity, you can think of the ID value of an entity bean. And for any given ID value should be a unique entity instance. So this is actually what Ebean has adopted as its definition of a persistence context. JPA also has that the entity instances and their life cycle are managed, which is where you get the idea of a merge and persist into the persistence context with JPA. And that's a JPA thing, and Ebean with Ebean, the persistence context isn't involved in persisting. And the way that that's achieved is that the dirty state for the beans is stored on the beans themselves, and that there's a JDBC batch buffer on the transaction. So those combined basically means that Ebean doesn't have this need for the persistence context as part of its persisting logic. Now, there's a little asterisk here. There is one aspect, which is that when a bean is deleted, with Ebean we need to remove that bean from the persistence context if it is in there. And that is because the persistence context also acts like an L1 cache. And so we remove the bean from the persistence context so that you don't then later try and find it and get it out of the persistence context rather than find that it's been deleted. So there's that little caveat there. But the takeout here is that Ebean uses a persistence context to ensure a unique entity instance. So let's have a look at some code and see what that means. So here I've got a query which is finding orders with IDs less than or equal to 10, order by the customer name ascending, and we're going to do an eager fetch for customer, and then we're going to output those orders. So when we output them to sysout, we get the order ID, the customer ID, customer name, and the identity hash code, which is the hash code of the instance, and that will sort of indicate whether the same instances are being used as part of the object graph. So if we run this in debug mode and have a little look, what we've got is orders, and if we scroll into orders we see 4 orders, and the last 3 orders here have the same customer 1 named Rob. And if we look in there and look at the customer, we'll see that it's sort of 2414 is the instance, and if we look into another one we'll see customer 2414. So these are the same instances of customer in the graph. And if we let that roll on, had a look at our output, we would see the identity hash code is the same for customer ID 1, Rob, identity hash code, and that's the same value for those last 3. So if we have a look at the SQL statement that's going on, and I want to just walk you through the mechanics of what's happening here. So here we've got our SQL result set, and when Ebean is converting this into an object graph, it basically is using the persistence context to check for or ensure unique instances. So the first one here is the ID for order. So it's saying order 2, are you in the persistence context? No. Okay, well then read order 2 details and put in the persistence context. And then at this point it says, oh, and as part of that, customer 2, are you in the persistence context? No? Okay, we'll read customer 2 details and put that in the persistence context. So when then we read order 1, no, it's not in the persistence context, reads the values, gets to here, customer 1, are you in the persistence context? No. Reads it, puts it in. And then so forth. We get to here, it goes, is customer 1 in the persistence context? Yes, it is already in the persistence context. I'll use the same instance for customer 1. So that one is reused and that one is reused. So all of customer 1, these 3, result in the single one entity bean instance for customer 1. Now I'm going to modify this a little bit. I'm going to fetch some more information. So I'm going to fetch the billing address and the details. So we're just going to fetch more of the object graph and run that. Cheers. Debug. So at this point we've got orders, and now if we dig in here, if we looked into order 1, customer 1 is Rob, 2413 is the instance, and if we look at the billing address, that's 2428, and that's populated as well. And if we looked at another one, we'll have the same customer, 2413 customer, billing address 2428. So that should be the same as up here. 2413, 2428. Okay, and then if we looked at the order, we would also see, sorry, the details are populated, and there's 3 details for this order 1. So if we let that rock on, and we get the output that we expect, no big thing there, but let's have a look at the SQL and just go through this mechanics again. Right. So we've run that query and we've got a few more rows here. So here we've got the order. Is order 2 in the persistence context? No. So it reads all of order 2. We'll make this a bit narrower. And we get to here. So actually let's just make this a little bit easier to read. So we've got the order, and then we've got the customer ID. So let's just make the alias cust ID. And then we've got, this is the address ID, the billing address. So let's just make it address ID. And then we've got, that's the order detail ID. So let's look at the detail ID. And I'm just going to remove some noise here. I'll just get rid of these guys. A bit more, why not? Okay, let's rerun that. So here we go. Read customer 2, that's not in the persistence context, reads it. Order 2, reads customer 2, no address, and order detail 4. Loads those into the persistence context because they weren't there before. Gets to order 1, no, that's not in the persistence context, reads it. Gets to customer 1, reads it. Gets to detail 1, reads that, and carries on, etc. Gets to here, and we've got customer 1. Customer 1 is already in the persistence context. So we've got duplicates here because we've done join to a one-to-many. So we've got an outer join, multiple details, 3 order details for that order. So these guys are effectively skipped because order 1 is already in the persistence context. Similarly, Rob 1 here, these guys are effectively skipped because when we read the IDs of 1, we'll find that the instance is already in the persistence context. So this stuff here isn't really read. And then we get to the details, and the details are read. So in effect, the persistence context is an important part of that object graph construction process where we're taking this relational result set and building the graph from it. And we're doing that using unique instances. So there's one thing to add, which is not quite that simple. We said you can skip this, and Ebean can skip this when it's already in the persistence context and the persistence context bean is fully populated. When there's partial objects involved, there's actually a merging process going. So for example, let's say the persistence context had Rob, one Rob in it, but we were actually populating, the name plus some other partial properties. What actually happens there is that we're doing a merge of that data into the persistence context instance. So we still have one instance, but there's actually a merging going on and not just a skip. Okay, so that's what I wanted to show you there. If we go back to the presentation. So the job of the persistence context is to ensure those unique instances. It's part of the object graph construction. Why do we want to do that? When we're modifying the graph, we don't want to have two customer ones, so that if we modify both instances and change them inconsistently, we've got a bit of a confusion and a bit of a mess. So we want to have just one instance of customer one for modification. The last point here also can be used when building object graph via document store, Elasticsearch or JSON. So we can use the persistence context when we also build via other sources, Elasticsearch in this case. We can skip that as well, but by default we typically want to build consistent graphs, and so this is used not only for relational but also building via JSON and Elasticsearch. Now the second example I want to talk about is the persistence context as a first level cache, and effectively this is because the persistence context is by default transaction scoped. So let's get into some example code here. So I'm going to look at this second example here where we're fetching some orders again, and then we have the second query here, which is find customer by ID. Now if I run this, what we'll see is the persistence context is scoped transactionally. So the persistence context is scoped for everything in here, which is this first query plus the second query. So I'm just going to I'm going to debug. So here, when we go orders, should we say customer is 2389, and if I look into the order detail information here, customer is 2389. So it's the same instance for this instance here, as well as the customer one in the orders. And if I let that run on, if we looked at the sysout, we would see that the identity hash code is the same for customer one as this guy here. So 41 blah 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 is the same as this. So it's the same instance. And if we look at our transaction, we see it's transaction 1001, and we only see the one select statement. We don't see the second find by ID. So this query didn't even hit the database. It went to the persistence context, found customer one was already there, and used that instance. If we didn't have at transactional, we just run it, we would see that the identity hash code here is different. So this is 19 something, and this identity hash code is 1529. So it's a different instance. And we can see the second select statements, find by ID. So this find by ID is running because there's a persistence context that's transaction scoped. If I just go back there for a second, we've got two transactions, 1001 and 1002. So these queries, there's no outer transaction, so they use their own and they build an object graph, and they use a persistence context that's scoped to that. Now, if we put this transactional back, we have this query doesn't even run. It uses the same instance from the persistence context, and that's why some people describe it as being an L1 cache. It's because in this context it looks like an L1 cache. Now this is kind of an in-your-face approach. If I took this code here and let's do a little bit, basically run the same sort of thing, but do it different. So ID is less than or equal to, so say greater than 3. So we're going to find a different set of orders and join to customer. And what we're going to see here is that if we run that, we'll see that the second order is order 4, and it joins to customer 1. When it does that, if you like, join or object graph construction, it uses the persistence context and finds the same instance of customer 1. So we can see that's the same. So I guess I'm trying to point out there's two kind of cases here. One is where find by ID, that's sort of in your face, and this one is more subtle. We're building an object graph in the scope of a persistence context, and we're joining to customer 1, and customer 1's already in the persistence context. Okay, now what I'm going to show you is when I modify this a little bit. Let's do this. So instead of doing a find list, we'll do a find each. Find each. Give me one of those thingies, and we'll just do a output of bean. Okay, and we'll do that now. Okay, so we'll run that. So instead of doing the find list, we're doing a find each. So we've got our query up here, and then we've got our second query here, which is only find a customer 4. This is not a very good example, so I'm going to modify it a little bit actually. But we've got a different hash code here than up here. So this is 13881605. Let's let's modify that a little bit. Greater than 1. That's better. So we did our first query, and then this is our find each query, and here we've got different hash codes here, identity hash codes for customer 1, even in the same query. And that's because find each is orientated towards very large queries, so thousands, tens of thousands, millions of object graphs. So the essence here is that if we did use a persistence context and it was scoped to the query, then when we use a very large query and populate it with tens of thousands of objects, that would use a lot of memory. So find each won't use an existing persistence context. It'll create its own little persistence context per object graph, and that's there's a little bit more to it, I guess, for fetch joins and such, but that's another topic, I think. But essentially, it's important to understand that find each runs with a per object graph persistence context scope. Now, the other thing I wanted to show you here was sometimes we do want this. So let's get rid of this find each for a second here. What I've done here is I've now said that we're going to run this query using a persistence context scope of query. So what this says is run this query using its own persistence context, ignore if there is an outer persistence context coming from an outer transaction. So in this case, we are going to see the query fire. So let's run that. So we see this query, so this transaction spans both queries, but this query does run, and this is the find by ID query. Whoopsie, excuse me. find by ID query, bind 1, and the hash code here, the identity hash, is different. It's actually a different instance. So kind of what we're saying here is that when we have this persistence context acting as an L1 cache, sometimes we don't like that. Sometimes we actually want fresh data, and so we want to bypass the existing persistence context, and so that's what this is for. So for example, if we had a bulk statement here, some sort of bulk update statement or something like that, or something like that, we want to hit the database and get the Roberto in a different instance rather than Rob. So we're running, we're getting identity hash code, we're running some sort of bulk update statement which is changing the name, and we want a different instance fresh from the database, and we want Roberto here instead of Rob. Okay. So yes, the persistence context can sometimes act as an L1 cache, and that's because it's by default transaction scoped. As a consequence of ensuring the unique instances, it sometimes acts as that L1 cache. We use the query scope to bypass that when, for example, we want fresh data out of the database. We've got bulk statements, things like that. And also note that find each uses its own special per object graph scope. So it does its own thing. So now I'm going to talk about sort of the concept here of the object graph that the query is returning, and specifically pointing out that when we use an Ebean ORM query, we're getting a snapshot of the part of the data from the database, as at a point in time, by default at recommitted isolation level. And the point here is that the database is doing some heavy lifting to enable high concurrency, and this is in line with what the database is really giving us. So what do I mean here? When we've got an object graph from a query, it's a snapshot. So it's a copy of data, some of the data from the database, at an isolation level at a given time. It's not the actual data. So for example, as soon as we get the data, it could be out of date by some other concurrent activity. And we're not trying to be the database. The database is doing lots of stuff to make this all work with high concurrency. And we're not trying to be the database from an ORM perspective. We're just trying to say, hey, here's a snapshot, a copy of part of the data that the database is giving us. And this is relating back to optimistic locking. So we're going to jump in here and look at what a database sort of looks like conceptually. So this is a bit of a generalization, but I think it's worth going through. And so to point out that this is specific to OLTP, if we're doing analytics and stuff like that, then other things we can sort of break a few rules. We can load data without doing transactional redo and things like that. So we're really talking about OLTP. And I'm showing you sort of a logical concept of an MVCC database. So here we've got customer 42, and they've got some blocks of their data, and we've got 4 versions. So we've got 3 previous versions of customer 42's data. So they've changed their name or their comments or something, and we've got different versions of them. And what we've got here is 3 transactions reading different versions of customer 42. So firstly, what version of the data should these transactions read? So transaction 90 is reading sort of version 2 of the data. This transaction's reading version 4 of the data. So the versions that the database will read is based on the transaction isolation level, and effectively what that means is that for serializable or repeatable read, that will be the version as at the transaction start time. And for read committed, it will be as at the statement start time. So let's say we started transaction 97 and we started our statement very recently, and this is the most recent version that matches the statement start time. So we read version 4. But let's say this transaction's running at, say, repeatable read. It started 5 seconds ago. So when we read this, we want to read the version of customer 42 as at 5 seconds ago when this transaction started. So we're reading version 2 data, which might be slightly different. Well, will be different because we've got version 2. So we're talking about MVC's databases. Why does this architecture exist? And basically it's allowing high concurrency, and you'll hear the term readers don't block writers, writers don't block readers. Effectively, we've got some immutable data structures here, or immutability going on. So when we have that, we don't need to lock a particular version in order to support concurrent requests. Here we've got 3 different transactions reading this data, customer 42, at the same time, and we don't need to worry about locking between those 3. The downside here is that we have now got multiple versions of this data. So we have typically a garbage collection sort of process going on that cleans up the versions. As the older transactions go away, we lose transaction 90, well, we don't need version 1 and 2 anymore. So those get cleaned up by the database in the background. So MVCC database is sort of doing background collection as an extra cost, with the benefit of having these multiple versions to allow very high levels of concurrent access without any sort of latching and locks, internal locks across this data. Now, so the point here is that Ebean ORM is expecting the default of read committed isolation level, and this is actually as per the JPA spec as well. So why is that? Effectively, optimistic locking only stops working at repeatable read and serializable. So at these higher isolation levels, what happens is that there is now a window of opportunity for a lost update. So if we have a transaction that started, say, 10 seconds ago, and now we're doing an update with an optimistic locking check, that update will see data as at the transaction start time, which was 10 seconds ago. So that 10 seconds is now a window where we can get the lost update anomaly occurring. So we have this sort of issue with the higher isolation levels. We can't use optimistic locking safely. And that means that we have to tend towards using pessimistic locking, and actually the application doing explicit locks. And when we add locks, of course, we're reducing the amount of concurrent throughput we can do. So if we can stick to read committed and we've got an MVCC database, then we have the effect of readers don't block writers, writers don't block readers, and we can use optimistic locking. So there's no explicit locking required to do that optimistic locking check. So this is kind of like the happy place for, I guess, most people. And to be fair, I'm a little bit MVCC biased, more than a little bit, I guess. Now, I'm just going to pop back here. If we were using a locking sort of type database, then we wouldn't have multiple versions of customer 42. And the other thing here is we wouldn't have this extra background process, right? So, and locking databases work really well when these transactions are really short, or the locks that are required to support these are sort of happy in the sense that there may be shared read-only locks. And then all 3 of these processes can run concurrently. Everything works fine. The issues we'll get with locking databases is when this transaction becomes very long, so it starts running more like many seconds, minutes, and it starts needing more than, say, shared read-only access. So we get more exclusive locking. So the 2 cases where we have long-running transactions that start doing shared locks across a lot more data, and those locks escalate from just row level to page and then up to table, or we get exclusive locking and that really blocks other locks. So that's where the issues of locking can sort of restrict the amount of concurrent throughput. That's why MVCC databases effectively can exist and are sort of competing against that. So we're coming to our conclusion now, which is, what is this persistence context thing? Its job is to ensure unique instances and to build a consistent object graph. For Ebean, it's not used in persisting, with the caveat here that for deletes, we need to also delete from the persistence context if it exists. By default, it's scoped to the transaction. We bypass that using a query scope. And if we're doing really large queries, find each while, then there's a special object graph scope that's used. And the last point here is that we really lean on the database for high concurrency. And the concept here is that the object graph that is returned from a query is a snapshot. We should think of it as a snapshot. It's valid. It's a copy. And what we're doing is we're using typically read committed isolation level, and we are using optimistic locking to, when we do updates, to confirm that the value in the database hasn't changed. And when we do that, we can do it all without explicit locking and get pretty good high concurrent throughput. So that's it. Persistence context in a nutshell. Thank you.